In mathematics, convergence tests are methods of testing for the convergence, conditional convergence, absolute convergence, interval of convergence or divergence of an infinite series. List of tests. Limit of the summand. If the limit of the summand is undefined or non-zero, that is, then the series must diverge. In this sense, the partial sums are Korchi only if this limit exists and is equal to zero. The test is inconclusive if the limit of the summand is zero. Ratio test. This is also known as D'Alembert's criterion. Suppose that there exists such that if r less than 1, then the series is absolutely convergent. If r greater than 1, then the series diverges. If r equals 1, the ratio test is inconclusive, and the series may converge or diverge. Root test. This is also known as the nth root test or Korchi's criterion. Define r as follows, where lim_sup denotes the limit superior. If r less than 1, then the series converges. If r greater than 1, then the series diverges. If r equals 1, the root test is inconclusive, and the series may converge or diverge. Integral test. The series can be compared to an integral to establish convergence or divergence. Let be a non-negative and monotone decreasing function such that, if then the series converges. But if the integral diverges, then the series does so as well. In other words, the series converges if and only if the integral converges. Direct comparison test. If the series is an absolutely convergent series and for sufficiently large n, then the series converges absolutely. Limit comparison test. If, and the limit exists, is finite and is not zero, then converges if and only if converges. Korchi condensation test. Let be a positive non-increasing sequence, then the sum converges if and only if the sum converges. Moreover, if they converge, then holds. Abel's test. Suppose the following statements are true. Is a convergent series. Bn is a monotone sequence, and Bn is bounded. Then is also convergent. Alternating series test. This is also known as the Leibniz criterion. If is a series whose terms alternative from positive to negative, and if the limit as n approaches infinity of is zero and the absolute value of each term is less than the absolute value of the previous term, then is convergent. Dirichlet's test. If is a sequence of real numbers and a sequence of complex numbers satisfying for every positive integer n, where m is some constant, then the series converges. Rabi-Damel's test. Let m greater than 0. Define if exists. There are three possibilities. If L greater than 1, the series converges. If L less than 1, the series diverges. And if L equals 1, the test is inconclusive. An alternative formulation of this test is as follows. Let m be a series of real numbers. Then if b greater than 1 and k exists such that for all n greater than k, then the series m is convergent. Notes: for some specific types of series there are more specialized convergence tests. For instance, for Fourier series there is the Dini test. Comparison. The root test is stronger than the ratio test. Whenever the ratio test determines the convergence or divergence of an infinite series, the root test is 2, but not conversely. For example, for the series 1 plus 1 plus 0.5 plus 0.5 plus 0.25 plus 0.25 plus 0.125 plus 0.125 plus equals 4, convergence follows from the root test but not from the ratio test. Examples. Consider the series. Korchi condensation test implies that is finitely convergent if is finitely convergent, since is geometric series with ratio, is finitely convergent if its ratio is less than 1, thus, is finitely convergent if and only if. Convergence of products. While most of the tests deal with the convergence of infinite series, they can also be used to show the convergence or divergence of infinite products. This can be achieved using following theorem. Let be a sequence of positive numbers. Then the infinite product converges if and only if the series converges. Also similarly, if holds, then approaches a non-zero limit if and only if the series converges. This can be proved by taking the logarithm of the product and using limit comparison test.